Okay, so we're going to talk about digital audio transmission, which is essentially signal flow of sound, so passing of sound from one device to another, but in the digital domain instead of the analog domain. Now, when we're working with sound, we often work in these hybrid environments where we're working with analog signals and with digital signals. It's important to understand signal flow on the analog side and on the digital side because we need devices like microphones, which are analog devices, in order to capture sound. But we also so often call upon digital devices like computers to manipulate sound and work with sound. So how this crossover happens, but also how the signal flow in the digital domain works is really important to be aware of. So just to kind of review a few things here, just to talk about analog signal flow for a second. We have a device like a microphone. So commonly we have something connected over XLR, so microphone cable, and that in order to be mixed or processed at a level that, say, a mixing board can understand it and work with it, that needs to be at line level. So in order to do that, we would go into a special type of amplifier for mics called a preamp. And so this is an analog signal going in, coming out of a preamp. It's still an analog signal, but now it's at line level. And something like this may be, if you're going into a mixing board, you'd have several preamps on each channel on a mixing board, and each of them would get your signal to line level, and then you could balance and add them all up. So you have a bunch of line level signals, for example. If you are going to work in the digital domain, say you'd go into something like a digital audio interface. So the way that works is usually we have preamps bundled into an interface. So if we kind of box this off for a second and say, all right, we connect our microphone into our interface, and then inside of our interface there's a preamp that gets it to line level, and there's also a converter. So a couple converters, but specifically, let's give ourselves some room here. Specifically, we'd be going to something like an analog to digital converter, ADC, which would then allow us to connect to a digital output of some sort. So say we're going to a computer, so the signal comes out over a bus like USB, and that's going to connect to our laptop, right? And in order to work with sound in the digital domain, we might be working with a DAW on that laptop, right? And so this is all in the digital domain. When we want to play back that sound, we might take that USB cable or right back into that USB, out of the USB, back into the computer, and then into something like a DAC, digital to analog converter. And so that's back as an analog signal. And then we might output that to something like a set of speakers or a set of headphones, for example. So that's a pretty typical hybrid setup for a lot of people at home, where you're going analog signal into a computer, so it has to get converted to digital, and then back out to analog so we can hear it, right? So we hear things in the analog domain. If we're talking about digital signal flow or digital transmission, we're talking about sending something out as a digital signal to another device that takes digital inputs, right? So we keep this in the digital domain, and we have some type of digital out. And what that looks like, it can be a lot of different types of connectors, which I can talk about in a second. And just as a few examples, places we might see this, that would include something like, if we're working in a studio, for example, it might be something like an interface talking to converters. And so we've sent our signal in, it gets converted, and then that's already a digital signal. That digital signal gets passed on to the interface, right? And so this would be an example of a digital output to a digital input. We do see digital I/O and so inputs and outputs and digital transmission all the time though, right? So looking at, say, USB, just the USB connector is a digital bus. It's sending binary data to the computer back and forth. That's another example. So we see digital transmission and digital inputs and outputs all over the place. Just a few examples. So HDMI, right? We're typically dealing with digital video and often digital audio. So that's a lot of different digital I/O in one cable. USB, like I said, DisplayPort, Thunderbolt, FireWire. There's a ton of others. These are just some consumer examples. We also have a bunch of them that pop up in the pro audio area. AES, EBU, SPDIF, TDIF, ADAT, LightPipe, MADI. These are different protocols that use different types of connectors and deal with transmitting the data in different ways. So I encourage you to take a look at them and check them out. One more recent thing that has really taken the audio world by storm is audio over IP or networked audio. Rather than requiring all kinds of extra infrastructure to sort of figure out routing signals over all these other protocols, a lot of companies and places are using their already existing network architecture, so their wired network, so their wired internet, and transmitting data over that. So that's a huge area of digital audio right now.